Hashtag how game developers actually make video games. Have you ever been completely absorbed in a video game, exploring a massive open world, experiencing a storyline that genuinely moved you, or executing a perfect combo in a fighting game, and wondered how any of this actually exists? How does an idea in someone's head transform into the complex, interactive experience you hold in your hands? The answer involves thousands of decisions, hundreds of people, years of work, and a process far more fascinating than most players ever realize. Today, we are pulling back the curtain entirely and walking you through exactly how game developers make video games, from the very first spark of an idea all the way to the moment it lands on your screen. Let us start with something that might surprise you. Video game development is not primarily about coding. It is fundamentally about problem solving. Every single element you experience in a game, the way a character jumps, the way rain looks on a windshield, the way an enemy reacts when you approach, all of it began as a problem someone had to define, then solve, then test, then refine. The process is messy, iterative, expensive, and occasionally brilliant. Understanding it changes the way you play games forever. The journey begins at the concept phase, sometimes called pre-production. This is where a small team, often just a handful of designers, a creative director, and maybe a producer, sits down and asks the foundational question: what kind of game are we making, and why would anyone want to play it? Studios develop what is called a Game Design Document, or GDD. This document can range from a few pages for an indie title to hundreds of pages for a major AAA release. It outlines the core gameplay loop, the target audience, the visual style, the platform, the estimated budget, and the overall creative vision. Rockstar Games reportedly spent over 8 years developing Red Dead Redemption 2, with an estimated budget exceeding $540 million including marketing. That level of investment does not happen without an extraordinarily detailed planning phase. For smaller studios, pre-production might last a few months. For larger ones, it can stretch over a year or more before a single line of actual game code is written. Once the concept is approved, either internally or by a publisher, the team moves into what is called production, the longest and most demanding phase of development. This is where the studio expands dramatically. A typical AAA game employs hundreds of specialists across multiple disciplines. You have game designers who create the rules and systems, level designers who build the actual spaces players inhabit, programmers who write the code that makes everything function, artists who create every visual asset from character models to environmental textures, animators who bring those assets to life, audio engineers who craft sound effects and implement music, and writers who develop the story and dialogue. Each of these departments works simultaneously but must constantly communicate, because a decision made by one team almost always impacts another. Take something as seemingly simple as a door in a video game. The level designer decides the door needs to exist in a certain location. The artist creates the visual model of the door. The animator builds the opening and closing animation. The programmer writes the code that detects when the player is close enough to interact with it. The audio engineer creates the sound of the hinges and the latch. The game designer determines whether the door should be locked, what unlocks it, and whether it can be broken down. That is at minimum 6 different people involved in one interactive door. Now multiply that across every asset in an open-world game that might contain tens of thousands of interactive objects. The organizational complexity alone is staggering. Game engines are the foundational software platforms that make this collaborative process possible. Unreal Engine, developed by Epic Games, powers titles like Fortnite, Batman, Arkham Knight, and the Final Fantasy Remake series. Unity powers thousands of indie games and mobile titles. Some studios build proprietary engines. CD Projekt Red built Unreal Engine specifically for the Witcher series and Cyberpunk 2077. An engine handles rendering graphics on screen, simulating physics, processing player input, managing memory, running artificial intelligence systems, and dozens of other technical functions simultaneously. Without a game engine, developers would need to write all of that foundational code from scratch for every single project, which would be essentially impossible at commercial scale. Artificial intelligence in games deserves special attention because it is one of the most misunderstood elements of development. When people talk about AI in gaming, they are not talking about the same machine learning systems making headlines in the tech world. Game AI refers specifically to the behavioral systems that control non-player characters. Enemy soldiers that take cover, companions that follow you intelligently, shopkeepers that react to your reputation. All of that is handcrafted by AI programmers using decision trees, finite state machines, and behavior trees. The enemy soldiers in Halo were so groundbreaking at launch in 2001 that players genuinely believed they were fighting intelligent opponents. In reality, Bungie's programmers had simply created exceptionally well-designed behavioral rules that mimicked intelligent tactics convincingly. After the core game is built, development enters the testing phase, more formally called quality assurance or QA. QA testers are professional players whose job is to deliberately break the game. They probe every corner, exploit every mechanic, and document every visual glitch, physics error, narrative contradiction, and gameplay imbalance they discover. These are called bugs, and even modest-sized games can accumulate thousands of them during development. Major titles like Skyrim launched with so many bugs that the modding community spent years patching them independently. Cyberpunk 2077 is perhaps the most famous example of insufficient QA time leading to catastrophic launch failures, resulting in the game being pulled from the PlayStation Store entirely and billions in lost market value for CD Projekt Red. QA is not glamorous work, but it is arguably the difference between a successful launch and a disaster. Alongside QA, developers conduct playtesting sessions with real players outside the studio. This is where designers discover that mechanics they spent months building are confusing, that a difficulty spike midway through is frustrating rather than satisfying, or that a storyline twist players were meant to find shocking simply does not land emotionally. These sessions force developers to confront the gap between their internal understanding of the game and how an outside player actually experiences it. The original design of Hades by Supergiant Games changed significantly based on early access player feedback before its official 1.0 release in 2020, contributing to what became one of the most critically acclaimed indie games ever made. The localization process is another element most players never think about. A game designed in Japanese must be translated not just linguistically but culturally for dozens of different markets. This involves rewriting dialogue to match lip sync animations in different languages, redesigning UI elements to accommodate languages that read right to left, adjusting humor references that would not translate, and sometimes altering character designs or content to comply with different regional rating systems. The localization process for a major title can involve thousands of hours of additional work and add significant time and cost to development. Marketing and launch timing are strategic decisions that profoundly impact a game's success regardless of its quality. Publishers analyze competitor release calendars, retail windows, platform exclusivity deals, and seasonal buying trends to position their titles optimally. The gaming industry now generates over $200 billion annually globally, making these business decisions intensely competitive. Games that release simultaneously against a dominant competitor often underperform regardless of quality, which is why you rarely see two massive open-world titles launch on the same weekend. Post-launch, development does not stop. Modern games are living products. Developers monitor player behavior data, track which levels players quit on, identify which weapons nobody uses, and observe where players spend the most time. This telemetry informs patches, balance updates, and downloadable content. Games as a service titles like Destiny 2 and Fortnite essentially never stop being actively developed. The original Destiny 2 launch content is virtually unrecognizable compared to what the game contains today, years later, with entire planets removed and entirely new systems implemented.